the wonderful, the amazing point slope or point gradient formula. With it we can find the equation of any line we like. There it is, in all its beauty. And when you think about it, all it really is the slope formula rearranged. The slope being y2 minus y1 and x2 minus x1. So here we go, standard sort of question. Find the equation of the line passing through minus 3, 4 and 2 minus 6. So you see that question, your thought goes, line. Well, in order to find the equation of the line, I need two things. Those two things are a point and a gradient. Hence the name of the formula. We have a point. Yes. Gradient. But fortunately, we have a formula. Yes. So let's use it. Okay. So the slope between these two will be -2. We have a point. We have in fact got 2 points. And the slope, we can choose which point we want to use. Y minus 4, minus 2 outside x plus 3. Playing around with that, there it is in general form. Okay. You'll see many variations of this. There's that one out there called the 2-point formula. When really it is the same formula, because all the 2-point formula does, instead of writing m, they write y2 minus y1 over x2 minus x1. There's another one you sometimes see, which is the intercept form. You've seen it, x on a plus y on b is equal to 1. Which is really handy if the 2 points you happen to know are the x-intercept and the y-intercept. It's a very restrictive formula. But I guess that falls into a line with the general equation for an ellipse and a circle and line. Find the equation of a line passing through 2 minus 3, parallel to 3x plus 4y minus 5. Well, hey, it's a line. I need two things. What are those two things? A point. We got a point. Excellent. Gradient. But we've got extra information. They've told us it's parallel to 3x plus 4y minus 5 equals 0. So if we find the slope of that line being -3/4, then the slope that we want is also -3/4. Point slope formula. Sub it in. There it is. That is, of course, how a mere mortal would do it. There, of course, is a much quicker way. If you've got it in general form, the slope is all to do with the coefficients of x and y. If they're parallel, then the coefficients of x and y have got to be the same. So I know the equation of the line has to be 3x plus 4y plus something is equal to 0. But I know it goes through the point 2, -3. So I can just substitute in and work out k. K is 6. There's the equation of my line. 3x plus 4y plus 6 is equal to 0. Probably a quicker way of doing that sort of question. Works for perpendicular as well. Find the equation of the line passing through 6, 4 is perpendicular. Same process again. We'd say, I've got a point, need a slope. But in this case, it's perpendicular to this line. So the slope I want is -4 on 9. Point slope formula. Play around with that. Bingo. There's mere mortal answer.
What
mere mortal answer. Us super mathematicians. Okay, well look, if it's in general form, just have a look at the coefficients of x and y again. Look at the line you were given, look at the line we got. Basically they swap around and the sign changes, and that's because negative inverse. So if I realise that, well, if it's perpendicular to 9x minus 4y plus 6, it must be 4x plus 9y plus something. So again, I can just substitute the number in, and we get k is -60. So there's our line. If I'm going to prove three lines are concurrent, so concurrent, it means they all go through the same point. What I'd do is I'd solve two of them simultaneously, so I've said L and M, and find the point of intersection. Now if that point of intersection lies on the third line, then it must go through that point as well. Thus, all three being concurrent. I think that's probably the quickest way of proving concurrency. Okay, that'll do us for theory today. 5D.